Boop, there it is. All right. So what am I going to do on this one? What do we do? You can absolutely box it if you want to. This is just big box. So if you want to do the box, we need to make sure we can get all three pieces in it. So we would need to do a 2 by 3 box. Boop, something like that. Totally valid. 100%. You can do the same thing. We're going to take our x minus 3. Cool. And we're going to multiply it by that 2x squared minus x plus 1. Absolutely valid. You can also do this with distribution. Either way, we're going to take our x times our 2x squared to get that 2x cubed. We're going to take our x times the minus x to get minus x squared. We're going to take our x times the 1, and that's just going to give me x. And then we're going to do our next set. We need to take our minus 3 times everybody or distribute it over here, either way. But our minus 3 times our 2x squared is going to give us minus 6x squared. Where did I actually read this orange? Minus 3 times minus x gives us a positive 3x. And our minus 3 times a positive 1 is just minus 3. No matter how you do it, whether you do it distribution or you do it in the box, you get the same pieces. We're going to take them out of the box, add them together. That is the chonkiest of highlighters, holy cow. Add them together. There's a little plus inside the box to help us remember if we forget what we're doing. We're going to combine some like terms. And we should have wound up around 2x cubed minus 7x squared plus 4x minus 3. I just didn't rewrite all the terms again. I combined together my like terms so that we have where I have my x minus x squared and minus 6x squared, and then my x and my 3x. I combined those together. Questions on that first one? Because the second one's super duper similar. We just have to build the thing first. We're taking our volume of this rectangle. I've got a width, I've got a length, I've got a height. Multiply. So we're going to take our 2x plus 4 times our 3x, can't see it, minus 1 times our 4x. Length times width times height. And you can shuffle the order on them, whatever order you want to do, but that's how we set it up. Then it's the exact same kind of vibe. I need to multiply 2 of them together, and then we're going to be doing 100% exactly the same thing. So we'll multiply these 2 left ones together first, because when we multiply, we tend to go left to right. Makes things easy if we have kind of a routine. I had to go grab my coffee. Unacceptable for me to sit over here without my coffee. Just unacceptable. So I'm going to take these 2 and multiply them together. And you can box it, you can distribute it, whatever you want to do. I'm going to distribute. So we're going to have our 2x times 3x giving us 6x squared. We're going to have our 2x times the minus 1 to get minus 2x. 4 times 3x to give us that 12x. And 4 times minus 1 to get minus 4. Our 4x is still just chilling over here. I haven't touched him yet. We're leaving him alone. I highly recommend, you don't have to, but I highly recommend combining our like terms first. It saves us a step later on. So looking at our 6x squared plus 10x minus 4 times that 4x. And we're almost done with it. Because this one we need to multiply again. And again, you can box it or you can distribute it. I am in fact going to distribute it simply because 4x, that's a monomial. That's one of those single piece things. Thank you, dear. The 4x is a monomial. It's a single thing. We're just going to distribute it. You can put it in a box if you want to. It's just going to be a 1x3 box. And that's kind of weird, but you do you. More power to you. Put whatever you want on your paper. So we're going to wind up with the 6x times the 4x, the 10x times the 4x, and the minus 4 times 4x. So 6 times 4 gives me 24. And x squared times x gives me x cubed. My 10x times 4x, 10 times 4 gives me 40. X times x gives me x squared. And 4 times 4 gives me 16 times x. So this is the answer to the first one. This is the answer to the second one. Okay. Questions on this one? First page. Okay. So, before we get into the next chapter, since we are going to be coming up on SATs here pretty soon, we're going to start having a little bit of extra SAT practice. This is coming from administration that we are doing this. So we'll just, like, after bell work, we'll have a little baby bullet problem that we'll do together that is from the SAT people, that is a practice that is either relevant or something we've done.
Do we put it in the...
We're just going to talk through them.
Okay, so we don't...
I'm not going to collect them. You can put them on the ball paper if you want to, if you need a little space. The ones that I've seen so far, we don't even really need to write it. We're just going to think and talk through it and see how we would approach it. And then we'll get into the next chapter. Like, 3/4 of the time, these things are multiple choice. So, the weird thing about the SAT questions is the wording, a lot of times. They will overcomplicate the words so much. I love it so much. So, don't stress about their words. Sometimes figure out what they're asking, and anything that they're chaotically typing in there, ignore it. They get extra with their descriptions sometimes. So we've got here the graph of the polynomial function f is shown. The y-intercept of the graph is usually given as 0, y. What is the value of y? Overcomplicated way of saying, what's the y-intercept? -3. It's where our graph of whatever chaotic polynomial this is crosses our y-axis. So all they're asking is, what's that? Okay? So sometimes these questions are, the math in them is simple. It's deciphering what they're saying. So find our little pieces in here. They give you a little picture right there. X is 0, y. So if x is 0, that's here. What's our y? We got to find it. Or what's our y-intercept? Any way that works for you to see it, they just have a whole lot of here in the way. Okay, so we're just going to practice looking at them. They like to be fancy with their language, but other than that, the math in them is sometimes not awful. Just as a reminder, when we're doing things like standardized tests or SATs and stuff, they're not just testing people who are currently in Algebra 2. They are testing people who are in geometry still. They're testing people who are in Algebra 2. They're testing people in pre-cal. They're testing people in calculus. So there's going to be concepts on there that are from classes you have not taken, and that's okay. You are not expected to understand and or guess the calculus stuff. I mean, toss a guess out. You never know. Sometimes, 1 in 4 odds on multiple choice. Who the heck knows? We've done those statistics. We can do that. 1 in 4, 25%. It's better than 0. But it's not bad to not know what the question even is asking. Give it a try. Give it a shot. And if we don't even know what they're saying, if they're saying words that we have never seen before in our life, it's probably not from our class. Okay? So, my little PSA on that. All right. So let's get into our next chapter, which is honestly super duper similar to our last chapter. We're going to still be living in the world of polynomials. It's just now, all these polynomials we're going to work with will have an equal sign. We've been in the world of expressions, which is a phrase. It's a mathematical phrase. We've been multiplying, dividing, factoring, whatever. And we have found roots, solutions, zeros, x-intercepts, those guys. But we weren't really like solving. That's what this one is. So our chapter 4 was called polynomial expressions. Chapter 5 is polynomial equations, which just means we're going to have equal signs in them. So we're going to be looking for solutions. Today we're going to be looking at graphs. So naturally, what that means is I have graphs. I'm going to give you guys graphs. So you don't have to try and sketch these in. I have them. They are of beautiful, definitely readable quality, and actually the numbers aren't terrible. And I definitely remembered to cover for you. Definitely did not run into them off this morning. Same thing with homework. Definitely remember to print that off yesterday too. I'm 100% all the way prepared for today. Okay. Yes, we did. Thank you. So these are the graphs we're going to look at today. Alright, so this is the very first graph. It's the very top graph on that little bookmarking thing I gave you. I know that's what we all want. Is polynomial graphs is a bookmark. Woohoo!
I want a bookmark. Just on the phone.
I was like, I have the plain white paper that was in between them. If you want that, you can put it down.
So what?
Well, when I printed it, there was a whole bunch of blank white space in between the sets, so I cut them out because there was like that much space in between. So I cut them out.
Smart.
Otherwise, I wind up with significant amounts of confetti. As we get bored and start ripping or cutting it up just to cause chaos. That's part of the reason I have the Roomba that runs during fifth period. Partly to clean up the confetti, partly because then my lights don't turn off. Because if I'm typing at the computer, it doesn't count me as a human, I guess. All right. So we are given this picture here. They've written the equation for us over here, but honestly, we don't really need it. I gave it to us. It's here, is what this graph is. But we can get everything we need for the rest of what we're doing here from the graph. We don't need the equation. So if you want it, it's there. But if you don't want it, I'm not concerned. Because my first question here is this even or odd? Odd. How do we know it's odd? The arrows go in opposite directions. So this is going to be an odd degreed polynomial because we know it goes in opposite directions. What are the roots of the function? Where do we have roots?
-3, -1, and 2.
Our roots are the same thing as our x-intercepts. And that is like the same exact color as that picture, and I don't like it. I'll take the pink. There we go. Contrast. So our roots are at -3, 0. I'm going to put them as ordered pairs this time since we're looking at a graph. And at -1, 0. And at 2, 0. So what are our solutions?
They're the same.
They're the same. we just tend to write those as more of x equals -3 and x equals -1 and x equals 2. If you write this for roots, I would 100% take that as well. They're the same things, roots, solutions, zeros, x-intercepts. Because what these are the answers we would get if I took our equation, and instead of having it as f of x, I set it equal to 0. And we solve it. So if I was to say factor it or divide something out, any number of ways to get down to those root solution zeros, x-intercepts. Those are the pieces we're looking for. So we're going to be spending this whole chapter trying to find those pieces or use those pieces in some way, shape, or form. So we can see those on here. And what we can do with this is from here, we're actually going to be able to write our factored form of the polynomial. I'm trying to see where I have it right now, which we'll do that later. Because we're going to practice identifying these pieces, making sure we know where they're coming from, and we'll see where those go. So we're going to do that same thing again with the next picture. Like that's all we're doing with that first picture. What are our roots? What are our solutions? So on this one, this really tall one, is this even or odd?
Even.
How can we tell?
Same direction.
Same direction. Our arrows go the same direction. Again, we have the equation here, so we could look at that one to tell as well. We can tell from our degree. Our highest power is a 4. So this is for sure even. Where do we have roots on this function? -1, 0. Mm-hmm. 1, 0. 3, 0. I think you said I was just talking at the same time. Or -2, 0. It's okay if we write it down in a chaotic order. Totally fine. You do not have to write them smallest to biggest. Traditionally, that's how it's done, but it's not wrong. The same things. Like I'm going to go right and left instead of going left and right. Is there? Same thing. It's the same thing. Just finding those roots, looking at those pieces. What do we notice about our degree and how many roots we're getting?
There's 4.
We have 4 roots and we had a 4th degree. How many solutions do we have on this one? 3. And what's our degree? 3. So we're going to start working through, and that's going to come up in the course of this chapter, how many solutions we're going to get on polynomials and when we have like enough information to stop looking. So we're going to use the information that's in there to help us figure that out. But mostly we're going to focus on our equations today. Boop. Okay. So that's all we're going to do on this one as well. So then we're going to take a polynomial equation and we want to find the standard form of this polynomial and find its roots. So two different pieces. So standard form, what do we remember about standard form? We talked about that in the last chapter. Say it again. Yeah, so it's going to have different pieces in here. We'll usually have multiple pieces. When we are in standard form, what that means is we're going to have no parentheses left. And biggest to smallest exponent order. There's 2 G's. Or exponents. There we go. Biggest to smallest order on our exponents No parentheses. So for this one, what do we need to do in order to find the standard form of this guy? Yeah.
The 3.
You can do it either way. Pick two things to multiply. We're going to have a couple rounds here. You can either take our 3 times the x plus 2, or we can take our x plus 2 times the x plus 5 and then distribute the 3. Either way is fine. I'm going to go with the left to right and then do it, but you should get the exact same answer. So to get this into our standard form, I'm going to take this and make this be 3x plus 6, and then I stop distributing the 3, x plus 5. Then we're going to do another round of distribution. I need to multiply the rest of these together. So now we're going to do just like we did in the bell work, where we distribute or do the box, however you want to do it. We're going to take our 3x times x, and we're going to get our 3x squared. We're going to take our 3x times our 5 to get a 15x. We're going to take our 6 times the x to get a 6x. And our 6 times the 5 to get 30. Sorry, my brain got stuck on that one for a second. And then we're just going to combine our like terms. I do have one set of like terms in here on those x's. So our standard form of this equation, we need to put it back as an equation. So we're going to have our f of x equals, combining our like terms together, we get our 3x squared. 15x plus 6x, we get our 21x plus 30. And that's our standard form. And whether you did that with the x plus 2 times x plus 5 first and then distributing 3, or if you distribute the 3 first like we did here, you should get the exact same answer. It does not matter. But this is our standard form. We just take the factored form and multiply it out. So this is our standard form, which I'm going to highlight blue because I did that one all blue stuff. But that's not all we were asked. We were also asked to find our roots. Where do we find our roots? Standard form is the blue stuff. How do we find roots?
You use the 3x plus 6 and then the x plus 5.
You can, but there's an easier one. What are you thinking, Caden? I heard an idea. It's like, I heard it. It popped in. We're actually just going to go all the way back to the factored form. Those roots are based off the factors. If we think back to when we did quadratics, because this guy's an x squared, it's a quadratic, we used to write it as like x minus r. Those guys, the r is our root, our 0, our x-intercept. So it's very much, when we would do our division and we take our factor and set it equal, those are the same roots. So we're going to take our factors, that x plus 2, and set it equal to 0. So what's one of our roots?
Negative 2.
-2. And we're going to do that with the other root as well. Just getting a slightly different green. With this guy, with my x plus 5 equals 0. So what's our other root?
Negative 5.
-5. So the factored form gives us all kinds of things. We've got our roots. We can use that to find our standard form. The roots are the same thing as those zeros, the intercepts, the solutions.
And what do we do with
The 3 is just a stretch or a compress. So that is an A value. If you think back to when we did A, H, and K,
Yeah.
all it does. So it doesn't change where our intercepts are. It's just going to do a stretch on this case because 3 is bigger than 1. So it's big kid yoga. So it's doing a stretch. Okay, so what we're going to do is we're going to take the rest of these graphs, we're going to find our roots from the graphs. We're going to write an equation in factored form and use that to find our standard form. So I'm going to walk you through the process. So here's our first one. So first thing I want to know is this even or odd? Odd, because we got those opposite arrows. So this is an odd function. Our leading coefficient on here, the number in the front, is that going to be positive or negative? The leading coefficient, is that going to be positive or negative?
Positive.
Positive. How do we know it's positive? The right arrow tells us that leading coefficient. The right arrow is always going to match. So if it's going up, it's positive. Where do we have roots on this one? Where are our roots? Mm-hmm. Yeah, I was gonna say they're counting by twos, so it's actually like smack dab in the middle. So we're gonna go ahead and call it 1, just because it makes my life way easier for this stuff. It's just the book counted by twos, and they're jerks sometimes. So I try and make sure we don't pick the jerk ones, but we have to use their examples sometimes. So the roots are great. I know the leading coefficient is positive. That's fantastic. And I kind of wrote the little piece we needed on the last page when we were talking about our roots. Because in order to build our factored form, we're going to take each of those roots and make a factor from it where we have x minus our root. So to build our factored form of this polynomial, I'm going to write it as a y equals. Our leading coefficient is going to be positive. I am not going to make you figure out what number it is. If you're writing an equation, it is either positive 1 or negative 1. Straight up. So if it's positive, I'm just going to put the positive one so we remember that that's what we were thinking here. And for each one of these factors, we're going to write it as x minus one of our roots. So I'm going to take my x minus 1 as that first one. My next piece is going to be x minus negative 2.
So that would be 4.
So x minus negative 2. And a lot of times that's how I'll write it, where I take the negative sign and have it make the double minus become a plus, just so we see where the plus came from. And then our last piece is going to be x minus negative 4, because x plus 4. And that's the factored form. To get from here to standard form, we multiply. Same way we did in the bell work, which I just, and then like a couple pages ago. So this one has 3 pieces, so it's going to take us a couple of rounds of multiplying, and yes, we are multiplying it out. So I'm going to take these first 2 and multiply them. That's going to give me my x times x, gives me an x squared. My x times 2 gives me a positive 2x. Minus 1 times x gives me minus x. And minus 1 times 2 gives me minus 2. And then we still have our x plus 4 over here. As we're going through these, we're going to do enough of these multiplyings. We might start to be able to do some of it in our head, and that's okay. For some of us, we'll be able to spot these combined like terms on the way. And if you do, that's totally fine with me. So then we're going to have our combined like terms here. We have our x squared, 2x minus x gives us just plus 1x, minus 2. And we have our x plus 4. I'm going to need more space, just so I don't have to squish it. There we go. So then we get to do that whole process again. another set of multiplying. So we're going to take our x squared times the x to get x cubed. Our x squared times the 4 to get 4x squared. Our x times x gives us that x squared. X times 4 gives us 4x. Minus 2 times x, and minus 2 times 4 gives us minus 8. And we're almost done. Oh my gosh. Because our standard form of this equation, all we got to do is combine our like terms. Make sure we are in biggest to smallest order. So we're going to have our positive x cubed. Our 4x squared plus x squared gives us 5x squared. Our 4x minus 2x gives us plus 2x minus 8. Okay, so this is our standard form. And if we think back to when we were looking at polynomials like originally, like way back in the day, when we have the right a value, so sometimes on the ones that we write, it's not going to be perfect because we're nice and don't make you figure out a. But if we have the right a value, this last number here, this minus 8, should be our y-intercept. Okay, so it's going to happen with a lot of things, not necessarily everything, but a lot of things. Okay, questions on this one, because this is like the big meat and potatoes of today. Let's do another one. I don't know that we'll get to the third one, and that's okay. Let's look at this one because this has a weird on it. So is this even or odd? Yeah, I heard it. It was quiet, but it was there. This is even. The arrows match. So we know it's going to be even. So when we get to our standard form, we should have an even power. Our leading coefficient, is that going to be positive or negative? Positive, because my arrows both point up. What are our roots? Negative 2, 0, and 3. Do we notice anything weird about our roots? One's at the origin. What else is special about that 0? Because this one, like on my negative 2, it goes straight on through. On 3, it goes straight on through. Yeah, it does what's sometimes called a bounce. If I just look at, oh, and I think y'all are stuck following my brain zooming in here. If I just look at those roots, this thing crosses where it looks like kind of like a line. This guy crosses kind of looking like a line, right? This guy kind of looks like a parabola where it's got a bounce. And what that is that this guy counts as what's called a double root. I am going to make this so you don't have to zoom in every time I zoom in to make my handwriting better. This is called a double root. And all that means is when we put it in factored form, we need to have it twice. But you can either write it out twice or you can just square it. Yes, dear?
So will it always be a double root if it looks like that?
If it bounces off, yes, it'll always be a double root. I was like, we shouldn't ever give you one with any higher powers than that because they don't look that different. So when we're looking at our factored form of this polynomial, if I write my equation, we've got our positive leading coefficient, so a positive 1's fine. We're going to take our x minus our roots. So I'm going to do my two regular ones first. I'm going to have my x minus that 3. Just because I tend to put the positive ones first just so that we see what's happening with the x minus part. If you want to do it the same order you wrote them, totally fine. It does not matter what order your factors are in. I just tend to do my positives, my negatives, and the weird ones at the end. So I'm going to have my x minus 3. I'm going to have my x minus negative 2, which becomes x plus 2. And then we're going to have our x minus 0. You can write it as x minus 0. We can also realize that thing is the same as x. Same thing. But I need that to happen twice. So you can either write it out twice because we have that double root, or lazy way, square it. Just put a little 2. I need 2 of them. Okay? So if it's got that bounce, it's gonna have a double up here. From there, to get to our standard form, we're gonna multiply this thing out again. And I don't know that we're gonna get the whole thing multiplied out, but I wanna at least get it started. So we have our x minus 3, our x plus 2, and x minus 0, that's the same thing as having x squared. So you can either do it like this. If you had that on a different factor, you would want to write out both full factors so that we multiplied it and didn't miss a term. So if it was like on the 1, we'd have x minus 1, x minus 1. Other than that, process is identical. We're going to multiply these two, and then we'll distribute him in. So we have our x times x giving us x squared, our minus 3x, and our plus 2x. I'm going to have minus 3x plus 2x, and that's going to give me a minus 1x. You can do and start to combine those pieces together if you're ready for that. I'm also trying to get us through so we're done. So we're done in time for announcements. And we have our minus 3 and our positive 2 to get minus 6. And this guy we will multiply against that x squared, and it's about to ding on us for announcements. So we'll distribute that through, getting x to the 4th minus x cubed minus 6x squared. We did wind up with a positive even degree function that has no y-intercept, so it's actually right there. And that seems pretty good. Okay, so we're not going to get to that last graph. That's okay. I'm going to pass out the first homework of this chapter. And you guys can absolutely do, you guys can do everything on it. We're going to work more with them tomorrow. We're not really, I was going to say, it's very much similar things. Tomorrow we're going to play more with some weird factoring things. Also pay no attention to the fact that the backside's upside down. Because again, I was totally ready and prepared for today. When I walked in this morning.
Are we gonna do the last graph tomorrow?
We will not do the last one.
Okay.
This is one of those, I would rather have done this one than that last one, because I wanted us to see that double. Alright, so we'll have this homework due, I think I have it listed as due on Friday.
Can I get the box, please?